Good afternoon. This is David at Semper. The National Electric Code references D-rating for electrical components. And the reason why a good rule of thumb is 20% is because there are power fluctuations on the grid over the course of the time of day and the course of the year, which can impact things. So I just wanted to demonstrate. So this is 60 watts. It's a 60 watt load on a 12 volt tap, and you'll notice that the input is 110.6 volts AC 111, and the current draw between the transformer and the lamps is 4.8 amps. This is AC voltage, and I put it on a variac here so that I could boost it. Now this is a 5 amp breaker, you'll see right there, and a 5 amp breaker is calibrated where it has a little bit of leeway, but a 5 amp breaker is calibrated to trip it when it sees more than 5 amps. If it's a short circuit, it will trip immediately. If it's an overload, it has a range of a period of time where over a certain percentage rating it will take a certain amount of time to trip. But if you exceed 5 amps, it will eventually trip. Okay, so now a transformer is an unregulated device, and so it will take whatever voltage it receives, divide by its turns ratio, and produce an output based on its load and the regulation of the transformer, a whole bunch of other variables. It will give you your output voltage. Okay, so I am going to boost this up using the variac here, and you'll be able to see the amperage change and the voltage change. So I'm going to go up to 115 volts input to the transformer, and you'll see we're up to 4.9 amps. Okay, now if we go up to 120, we're over 5 amps. Now the power company typically in the United States will tell you nominal 120 is plus 5% or minus 10. That's their acceptable range. So 120 plus 5% is 126. 120 minus 10% is 108. So anywhere between 108 and 126 you could be reading. So at 5.1 amps, that exceeds the rating of this breaker. So this is the risk that you run if you size the breaker. If you do put the breaker is capable of handling 100% load, and the day you installed this, perhaps it did not exceed the load, but the conditions the day you made the installation may not be the same conditions a year later or a week later. So instead of loading in this example, a 5 amp breaker with 60 watts of 12 volt lighting, which if you divide 60 by 12, that's 5 amps, you're right at the limit of the breaker. So depending on the conditions in the field, it could lead to nuisance tripping. Now, the National Electric Code references and other general rule of thumb is a 20% D rating. So instead of 60 watts, we just have a single 50 watt lamp, which is 4 amps on a 5 amp breaker. Now, the other thing you have to beware of is that the input voltage is going to determine the output voltage. So if it's calibrated to 11.5, 12 volts, whatever the voltage you decide to put this lamp at, and your input is 110 volts into an unregulated device like a transformer, then as the voltage changes, the output will change as well. So if the input is significantly below 120, like down at 110, then you could see an increase in lamp voltage. And an increase in lamp voltage means it's going to run hotter, and it's going to put out more light output, but it's also going to decrease the life of the lamp. And the purpose of why I'm shooting this video is to show that it can lead to nuisance tripping as well. Now, by derating the breaker, you will almost guarantee that you're not going to have nuisance tripping due to overload based on these changes in field conditions. Now, if I step up the voltage to 120, you'll see that the amperage goes from 4 to 4.2, so it's still well below the 5 amps. Even if I go up to 125. If you have any questions, send us an email, give us a call. Have a great day. Thank you.